Hey folks, welcome to this geometry nodes tutorial. We're going to be starting to look at fields now on this channel, which is kind of the new way that geometry nodes works. I've not touched it yet because there were so many changes and new nodes coming in, and it's finally started to slow down enough to where I think that anything which I teach you is going to stay relevant. So that was kind of why I was delayed on this. This video is kindly brought to you by SKILLSHARE, more on them later on. And in this one, we're going to be making a hexagon world. So this is completely inspired by this post by 80 level, the Christos Stavridis one. Just a very cool little project with all of these different hexagons being driven off a texture to give them different heights, different like sea levels, water, different colors. We're going to be going not exactly the same way. This was all done with Houdini. We're going to be doing this obviously in geometry nodes, and we're going to be using some different techniques to give us the different colors, whereas this was all driven off the height per instance. That's something that we will be able to get to, but it may not be until Blender 3.1. So we just need to hold fire. We've got a different technique to work on today, and I'll show you what that is. Jumping into Blender here, I have got my geometry nodes workspace, and we're just going to add an object, any object, create a new geometry nodes tree, and I'm going to delete that group input. So this is essentially just a container for our hexagon world. I'm going to go ahead and rename this one to Hex World. There we go. And now let's jump in here. There's no convenient way for us to make a hexagon grid. If you're familiar with Sverchok, then you may be aware that there is a polygon grid node that can do things like hexagon grids in various tessellations. So you could do a hexagon of hexagons, and we're going to be doing this with geometry nodes, but we don't have the node, so it's going to be a manual process. Hopefully that's all right with you. Let's get into it. So back in geometry nodes here, the way that we're going to be starting is with a mesh line. And this is just a nice easy way of working, generating a bunch of points where we can set the position for them. And this is something which is going to be, you're going to get used to this workflow when working with fields. Instead of using attributes, we're just going to simply calculate vectors and it's going to assign them by index. So it's a really nice way to work. If you haven't touched the fields branches yet, then this is a good exercise to get into it with. Just to save us a little bit of time, what I'm also going to do is I'm going to take my mesh line here. I'm going to go Control G to group it. And I'm actually going to just go ahead and delete from the group front those two options. We aren't interested in the actual positions of the line. We will just be interested in the count itself. So I've got one which I'm going to call count X, and I'm going to take another one which I'm going to call count Y, and I'm going to multiply these two together. So think of this as making a kind of rectangle grid. We have our X multiplied by our Y, and that gives us a number of points for the full thing, right? And all of our points are contained on this line, so that's why we're multiplying them together. If we want a 10 by 10 grid, we need 100 points. That's why we're doing this. We're also interested in our count X being passed out because we're going to be using it in some of our calculations for actually generating the grid. This is fine as it is here. So just count X, count Y on the front, multiply those together, they go into our line, and then pass through your count X. Okay, I'm going to tab out here, and I'm just going to call this one points, just because it is our point generator. So we have a lot of different options, which, you know, we're not looking at attributes anymore. So our attribute submenu is basically empty. And instead what we're going to be doing is working on things like the index directly. So we'll be creating vectors based on their relationship to the index. For example, if you want to position stuff in a line along the x-axis, you may say that the x offset is just going to be the index. So it would go like 100, 200, 300 along that line. So that's essentially what we'll be doing here. Let's take our index, which is an input node. I'm just going to drop it in here, and I want to set the positions of my line. So under geometry, set position, we can do this here. So if I just add another node here, the vector combine x, y, z, you'll see what I mean. So if I plug this into my positions, I can now set the positions, for example, based on the x of, so the index is the x position, and we can see we have this line going up in X. The way that a grid works this might seem a bit odd to be thinking about this, but essentially we are going to be drawing a line like so. This may have a number of points, so like 1, 2, 3, 4, 5. And these indexes will actually be 0, 1, 2, 3, and 4, right? As we always start our index at 0. And then we want our grid to go on to the next line and the next line. So then it's going to come like so and like so. And this will be 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And that would be a 3 by 5 grid, or sorry, 5 by 3 grid. So the way that we want to do this is that our X goes in the position 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, right? And then we'll manage the Y separately. And to do this, there's a really simple math node. Formula is the modulo on the math node. So if I just set this to modulo and I set this to 10, then what we have is a line that goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, which is 10 points. And then it'll restart 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And because we have this 10 times, right, so it's 10 by 10 grid, it's just going to stack those things, right? We haven't done anything to the Y. And this is why we're passing out our count X as well, just because I can pass that through directly and that's going to do the maths for us. Okay, how do we get our Y offset? This time what we want to do is we want to take our index and instead of going 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, or, you know, whatever, in index order, we want it to go like 0, 0, 0, 0, 0, 1, 1, 1, 1, 1, 2, 2, 2, 2, 2, and so on, like indexes, but all of those, that single row is clumped together. Nice easy way for us to do this. Take your modulo, Control-Shift-D, so it brings the inputs, and we're just going to divide it, okay? So we have our index now being divided by 10. So what happens is we have 0, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and then it's going to go 1 when we get onto the next line. And this is really useful because it means that we can use another operation called floor, which just rounds down to the next integer. So like 0.6 will become 0, and this means that we will get that 0, 0, 0, 0, 0, 1, 1, 1, 1, 1, and so on. Okay, so divide and then floor. If I plug this into my Y, there you go, you can see what is going on there. We have a bunch of points, and then it jumps up to the start of the next line, and the next line, and the next line. So far, so good. There's going to be a couple more things that we do, but first of all, I want to actually throw a hexagon on this so that we actually know what we're looking at. Previously, the node that we would have used was the point instance node, and in this case, what we'll be using is the instance on points node. It's a subtle name change, but it has a few more options, and it allows us to do a bunch of really cool stuff. So this node has a green instance socket, which means that we can actually instance geometry. So if you generate geometry in the node tree, you can instance it in the same node tree. Amazingly useful. We also have a selection. This allows us to say yes or no to certain points. Pick instance is a kind of an on or off. We have an instance index. So if you have a collection of instances, then you can basically say like, okay, instance number 0 goes on these points. Number 1 goes on these points. Number 2 goes on these points. We're going to be using that later because we want our different levels like water, sand, grass, stone, snow, and they're going to be our different kind of Z positions, and we're going to instance them in that way with this socket. Then we have our rotation and scale controls, and these are on the node itself. So it's no longer an attribute called rotation or scale. You just plug it into the instance node and you're good to go. What we are looking for is a mesh primitive cylinder, and I'm going to leave it all as defaults except the vertices, which I'll bring down to 6, and that's going to give us a hexagon. Now I want to space these out a little bit more so that I can actually see them. They're all overlapping at the moment, and to do this, we just need to add some multiplication into our maths here. I could do this with a vector math node afterwards, so that's in the vector math. You will see me using the quick favorites. I just have math, vector math, and map range in here, just because they're used all the time. And let's just multiply these all by 1. So now I can change my X scaling and my Y scaling just on this vector math node. Now, something that is going to be important is I want my rows to be like horizontal rows, which means I want these to rotate slightly. So I want these to be like flat edge against flat edge in their own row, and you'll see why when we start to get them like really close up together. So what I'm going to do is I'm going to rotate just on the instance on points node rotation. Let's set this to 30 in the Z, and that's just going to rotate that nicely. And now I can squeeze these in correctly here, and we can see that that is around about 1.7. The actual number is the square root of 3. If you want to know about hexagon derivations and making hexagons and things, I will leave a link to a video about making them in shaders that I did before. It's the same maths, so we're just doing the same maths here. Just type into here in our X, SQRT for square root, open brackets, 3 close brackets, and that's going to be perfect there. Cool. Now what I want to do is have some control over this. I believe it's 1.5, but I might want to tweak that later for the Y value. Now we want every other row to offset sideways. And again, it's just all the same maths that we use for making like fabric weave and knitting patterns and stuff like that in shaders. If you're familiar with shaders and procedural shaders, then coming into geometry nodes fields is going to be quite natural for you. I have the floor value here for my Y, and this is essentially a row index, right? We have row 0, 1, 2, 3, 4. And all I'm going to do here is modulate this at 2. So we get 0, 1, 0, 1, 0, 1. And I'm going to add this to my X. There we go. So that is pushing it much too far out. We only actually want to push out by half a step. All we need to do here is make sure that we are dividing that modulo by 2. So just multiply by 0.5. And there we go. That's how you make a hexagon grid. So nice and simple. Just a few little bits of maths to get things kind of weaving around as you want. All right, I want to now center this grid. Center it. There's a nice easy way to center things, and let's have a look at that. So we're going to grab our geometry bounding box. I'm going to drop this in like this. And what I want to do is I want to find the min and the max values, and I want to add them together. And then I want to halve it, and I want to offset the position by that. So it's quite simple. Just take your min max into a vector math node, set to add. We are then going to, oops, not on there. We're then going to scale this by, sorry, not 0.5, by minus 0.5, because we want to move it in the opposite direction. And then we're going to use another set position. This time I'm going to turn on offset, which just means that we're pushing the current positions in a different direction. And there we go. So nice and easy. Now in this case, it doesn't actually matter whether you use the the max or these two added together. But if you're doing this on a more complex geometry, which is not on that corner at 0, 0, then just adding them together makes that difference. Okay, so we've got a little bit further. Now, what I want to do is actually manually center this a little bit more. So we've got it like in the general center, which is great, but you can see because of this kind of half offset, it's not like perfectly centered. What I'm going to want to do here is actually add 0.25 to my X. So I'm just going to, just because it's splitting the difference of that 50% offset, right? So we can take our geometry, transform, and move it in the X. Let's go this way. It's not 0.5, it's 0.433, which is just a number to remember. There we go, that's perfectly centered now. The reason it is 0.433, so the radius of one of these hexagons, I'm sorry, I know it's a bit weird maths, but the radius of one of these circles is like the center to the point, the corner, and that is a length 1. So this distance here is actually less than 1. It's 0.866. You could just do the trig to work that out, but remembering it helps as well. If you do hexagons fairly frequently, you will remember those numbers, the square root of 3 and 0.433. So we now have this centered exactly on a hexagon, and that's very important because when we mask these, we have this square of hexagons, which is cool and all, but we want a hexagon of hexagons so that we get the same look as we had on a cool little hexagon board thing. So I'm going to make my hexagon grid a bit bigger. Let's go to like 50. There we go. I'm just making sure that I'm leaving a point in the middle. I have 250,000 hexagons and my viewport is very laggy because of this. You may want to start out with a lower number, something around like 200 perhaps. Let's go with that. And then we're just going to make sure that we have, if I reduce my Y here. Okay, so now what we want to do is create a hexagonal mask, which is going to allow us to delete points which are outside. The temptation is to use the Boolean, but don't, because the Boolean is not going to work. For a start, we don't have any faces, and secondly, where you have intersections, like where it cuts something, it'll generate more points where you don't want them. So what we're actually going to use is the geometry, delete geometry, and all we need to do is create a selection. Now, for us to be able to see what's going on, I'm actually going to leave all of these hexagons visible, and we're going to plug it into the scale as we go, because at the moment it's really difficult to actually debug a node tree and see things. So let's just go ahead and add a texture, gradient texture. Again, this is one of the great things about fields. We've got texture nodes inside the node tree. There's a lot of stuff about fields which I'm kind of skipping over. Things like, why do we have diamond sockets? And why do we have dashed lines? Frankly, it doesn't matter. It doesn't matter. If you're using a vector, the vector goes into the vector. If it's a circle and it's a solid line, that's like a solid continuous value. Like this minimum vector is going to be like a constant vector, whereas like this one over here, because it's being driven by the index, it's different for every index. That's kind of the long and short of it. Anyway, the point is we're just going to be taking the factor of this and plugging it into our scale. Okay, things have gone a bit crazy. We're interested in the radial gradient, which is a 0 to 1 in a sort of polar direction that goes around in a radial direction. And we can see this, we have 0 coming around all the way up to 1. Now we want to do some maths to this. And again, if you're interested in getting a bit closer to the maths, the hexagon tile pattern video, which I did for shaders, that actually talks a little bit more about the maths and the trig and things. Okay, so we've got the gradient texture. We don't actually need a vector plugged in. If it doesn't have a vector plugged in, it will assume you mean the position. I mean, you can just plug in the position node, right? If you take the input position, this is going to do the same thing, but you don't need to. So I would only bother plugging something in if it's like a different vector. What I'm going to do is take this vector, I'm going to multiply it with a math node by the number of sectors that I'm interested in, which is 6, because we're trying to make a hexagon. So let's multiply it by 6. I'm then going to floor this so that I have 0, 1, 2, 3, 4. And I'm also going to then add 0.5 because I'm not interested in the start of the vector, like where this is 0 angle. And that's essentially what we're doing here. We're generating the angle around the pole. So I'm not interested in where it is pointing out horizontally. I'm interested in where it points to the middle of each sector, which is going to be like the 0.5, 0. Or 1.5, 2.5, 3.5, 4.5, and 5.5, which is what we have now. If I then divide this by 6, then what we have is something that we can multiply by our full circle, right? So we have, if we multiply this value in here by 2 pi, then that is going to give us the angle from 0 to halfway through this section. And equally for this next one, it's 1.5, so it'll be from 0 to 1.5. That's sort of what we're doing here. And the reason that we do multiply and then pre-multiply post-divide is just because it helps us do the maths, right? Rather than needing to know what 1/6 is, then we can just multiply, work in whole values, ones basically, and then divide it afterwards. We're going to now just take this, multiply it by tau, T-A-U. That's going to give you your angle. Make a little bit more space here. And then what we need to do is actually turn this into a vector. So if you have a triangle, I'm just sort of doing this quite arbitrarily, and you have an angle here, theta, and that's what we've just calculated, right? This number here is theta, radians, and we have a right angled triangle because we're interested in our x values and our y values. So if we assume that we have a vector length of 1, so this hypotenuse is 1 meter, this helps us simplify it, but it also means that all of our maths is in terms of like multiplying and proportions, and It just helps everything stay very simple. Right, so our triangle has a hypotenuse length of 1. We have our x now, y, as our adjacent and opposite sides. You'll hear people talking about that when they're talking about trigonometry, the adjacent or the opposite or the hypotenuse. So if we have sine of the theta of our angle, this equals the opposite side divided by the hypotenuse. This value here is equal to sine of theta. In our case, the hypotenuse is 1, so we can get rid of it because we're just dividing by 1. And the opposite side is y. Let's replace that. So in terms of our vector, sine of theta, we have theta, is y. And cos, this might not be a surprise at this point, is adjacent over the hypotenuse. Hypotenuse is 1, therefore we can just be left with the adjacent, which in this case is x. So you can just use this angle that we've generated, put it through sine and cos, and that will give us our x and y component of the vector. All looking good. So we have this. Let's grab cosine. This one is going to be our x, and sine is going to be our y. Let's make a bit more space. And we're going to use a combine x, y, z in our x and y. Here we go. This is going to give us our vector. So this is a vector pointing out into the center of each sector, like so. And then what we need to do is the dot product. I know I'm throwing maths at you, but essentially this is how we can do it. So we have our vector math node, find the dot product. We're taking our vector and the position vector. So this is just our general overall coordinates. And I can plug this in to the dot product like so. And now you see if I plug this into the scale instead, and I'm just going to use a map range node. If I, here we go, reduce that a little bit, you can see that what we have is a gradient from 0 at the middle going up and out. So what this means is that we can actually use this. We can basically say, where is this less than some value, and use that as our selection mask to remove points which are outside the hexagon that we're interested in. So I know that was a bit of a trudge to get through the maths there if you're not used to it, but it does give us very accurate selection areas. And a selection, if you're used to shaders, a selection is simply a black and white mask. So what we've done is we've created essentially a value per point, and we can say, is this greater than or less than a threshold? And where it's less than, we want it to say no, and where it is greater than that threshold, we want it to say yes, and then we're going to delete those points where it says yes. That's essentially what we're doing here. There's a nice node for this called the float, compare floats. So this one allows us to take a float in and it will output a boolean, just a yes, no. So if I plug this in, and here we go, we're going down actually, so negative values, but you can see what's going on. We're creating now a hexagon of tiles. I'm actually going to leave this at -20. And that's basically just going to give us hexagons that are within this space. Cool, cool. So now we have all of our hexagons and they're masked. And that's actually a large part of the challenge here. Let's talk about SKILLSHARE. SKILLSHARE is an online learning community with literally thousands of classes. These are in a range of topics, from things like fine art to illustration and business management skills. You're really covering all of the kind of professional skills for a creative individual who wants to elevate their work. One that I've been following along with at the moment is Do Things Tell People, The Power of Personal Branding by Hamza Khan. So good for taking you from just, from making the work that you make to engaging in that work with a broader community, a broader audience, and creating some kind of brand and brand presence around the work that you do. And that's obviously so important. If you're wanting to turn something into a living, whether that is as a full-time creative individual, or if you're just wanting to elevate your work ethic and go for things like raises, having that personal branding is so important. Something that he talks about a lot in this class is storytelling, and about how you're not pushing a brand, you're not pushing a business. What you're really trying to get people to engage with is a story, trying to get people to connect with your story, your brand's identity and its reason for being. I've been working through this one and I've been really excited about getting engaged with the different exercises. So I've done things like making my own website now, which is in progress, but it's on its way. And yeah, there's a lot of really cool stuff in here, a lot of really thought-provoking stuff to get your teeth into. If you're the kind of person who enjoys learning through this kind of video seminar, then I definitely recommend this course. There's so much to get your teeth into. There's so much to look at, and Skillshare is all about that. You know, you just sign up to a class, jump in it. There's no adverts, no distractions, and you can just engage straight off. Leave comments, talk to the community, talk to the instructors, and yeah, you can get to really push out some projects and just have fun with it. Have fun in learning in this way. If this sounds like something that you'd be interested in, then check the link down in the description as well as the pinned comment. The first 1,000 of my subscribers to click that link will get a full month of Skillshare Premium. All right, let's get back to geometry nodes. And what we're interested in here is how we can now scale these and move things around and have a little bit more control. I'm actually going to do this with empties because it can just be nice to have a bit of 3D viewport control. Makes it easier to animate if you want to do, you know, little turnarounds and things like that. So then what I'm going to do is I'm just going to add 2 empties. I'm going to add a cube empty. Here we go. And I'm also going to add a sphere empty. Here we go. I've got these 2 here. I'm going to call the cube world and I'm going to call the sphere texture. And these are going to control the density and height of the world and the density of the texture and position. First of all, we're interested in the world one. So let's go back to our node tree. I'm actually going to pin it just so that I can click on other stuff without it going away. And I want to bring in my world empty here. To make sure that we're always looking at where this is kind of relative to our object, we can set this as relative. And now all we need to do is add another transform, because I want this to not affect our offset there. I just want this to be changing the scale of this. So you can see if I now scale this up or scale it down, you can see that this is moving our points accordingly. Now, just to make sure that everything lines up with our hexagons, I'm also going to plug this into the scale down below on the instance on points. So now what happens if I scale this is the whole thing gets bigger and you can see this kind of jumping as it loses edges because of our mask, right? We're masking it within that 20 meter area. Cool. So this is working perfectly. I'm just going to leave that there just so that we can get things nice and visible. And now what I'm interested in is controlling the height. This is where stuff gets a little bit more landscapey. At the moment, we just have some hexagons in a nice little pattern. What we were interested in is changing the height of them based on a texture. You could use an image texture, not as of today, but there are commits coming for the rest of the textures. Right now we just have things like noise, Voronoi, white noise, and gradients. We'll be using the noise texture anyway today, so it doesn't matter that we don't have that image texture, but it will be added anyway in time. First things first, let's change this to 2D because we're only really interested in that like top-down projection. And for convenience, I'm also going to turn off the detail. Next thing we're going to do is I'm going to actually duplicate my position and I'm going to plug it into the texture. Now, I said before, don't bother plugging things in because it's automatically going to use it. However, in this case, we want to control the position, scale, and rotation of our texture with the sphere empty. So let's go and drag that texture empty that we made before. Let's set it to relative. And we want to do some things to the position vector. For visibility, I'm actually going to just plug this into our scale. And I might also, there we go, just reset that. Instead of color, let's use the fact so that it's even and we can see what's going on. I'm going to move my 2 empties off to the side as well, just so I can see them a little bit better. So I have my texture. And what I'm going to do is I'm first of all just going to add a bunch of math nodes and vector math nodes. So let's just add the location. That's the first thing to do. Next one's rotation. So we're going to add a vector rotate, set this to Euler. And we're just going to plug this into the rotation. And then we can also set our scale, which we can do with a multiply. There we go. All right, now let's look at what happens when we do stuff. If I move my empty to the right, the texture It's changing too fast. So let's reduce the scale down to 1, maybe even lower here, 0.3-ish. So if I move it to the right, the texture goes left. So I need to change this add to a subtract. And now we can see that this goes in the correct direction. Cool. If I rotate it, it's actually rotating the wrong way. So let's invert that that vector rotate. And now it rotates correctly. And what happens if we scale it? Well, again, I want it to go the other way. So let's set that to divide. And now you can see that we have a nice little control following our empty. Awesome. So when you're working with like positions point data for your textures, you often feel like you're doing things backwards if you're using a controller in this way. So just to be aware of, subtract, invert your vector rotate, and then divide. Now we don't want to control all of the parts of our scale here. We're only interested in the Z component of our scale. So let's go ahead and just join up our original value from the world one. And I want to multiply this by a vector which contains the noise texture in the Z. So let's go ahead and add another vector math node. Just delete that one there. And we're going to be multiplying by a vector combine XYZ. Let's start off by setting this all to 1, just to make sure that we don't have any sort of loss there. And what happens if we just plug in our noise to the Z? It's all right, it's getting there, but we have a few more steps to do. So first of all, I want to set up my texture a little bit. So let's use a map range, which you'll find under utilities, map range. And I'm just going to clamp it in a little bit. So you can see where these go white when they're actually being multiplied by 0. So I'm happy to lose some of them. I'll go for maybe 0.2 or something is fine, because we can always set our 2 min, which is the actual value that gets multiplied out. But I want to make sure that I'm like touching the end of that noise texture. We can then, at the other end, if I flip my input and output, so sorry, the 2 min, 2 max, which is our output values here. If I flip them around, then I can do the same thing, reducing my from max until I see that some of these are starting to go down to 0, which is our 2 max value now. And then I'm just going to set these back to the correct direction. Right now, this is all looking quite bitty. And to rectify this, let's go ahead and scale down our world one, which is going to give us a little bit more resolution. And then I'll also scale up my texture one, which is going to make this a little bit smoother. So now you can see as we change this, these all get scaled up. Now there is a little bit of an issue, and that is that we have the same on the bottom. And this is because our cylinder is not centered on its base, it's centered on the bottom, centered in the center. We could always just use a geometry transform and move this up in the Z-axis. And that solved that. When we actually come to make our own cylinders, which we're going to be using to tessellate different materials in different places, we're essentially going to do the same thing. We'll move the origin to the base. We can see we have a few flat patches, so let's make sure that we have nothing coming out as 0. And this is all starting to look pretty neat. I can do something like changing up my distortion, maybe 0.5, just give it a little bit more interest. You can always set some detail if you want detail. And again, you could change your scales on here, just to make things a little bit different. I'm going to set mine down to 0.1 just so that my empty has a bit more, it's a bit more sort of neutrally scaled. There we go, all looking really cool. I like how this is coming out. We're now going to do something which is optional. On the example, you can see in some of these that we have this sort of sea level hexagon. I don't really know what else to call it, where they have removed hexagons which are below a certain level in the noise, and they have replaced, or they have put in a hexagon inside which just sort of fits that whole area. We're just going to do the same, basically. I'm just going to put in a hexagon. I'm going to delete other hexagons. So to remove hexagons, we're going to use this selection input. And I want to find hexagons which are below a certain value. There's lots of ways to do this, and you can always try and make things work together as much as you can. I'm going to do it a little bit more haphazardly because I'm not too concerned. I want sort of different controllers so I can change the sea level compared to how many points I'm removing. So I want that separate for mine. What I'm going to do is I'm just going to delete certain points here. So I'm going to go for greater than, in this case 0.2, which is where we're clamping our map range. And I'm going to plug this into the selection option. So right now nothing except from these three gets deleted. We can always increase this and you can see what happens there. Certain points get removed and you can set this however you want. Now you could also set it after your map range if you are inclined. You can also make this a little bit steeper by changing it to smoother step. Or you could even do something like stepped linear if you want this sort of terraced look, which is a bit more Minecrafty if you're into that. So I might set mine to smoother step just because it gives us a little bit more interesting variation. And I'm going to set mine just in here, about 0.2, something like that. And now what I want to do is I want to create a hexagon that fits the board. The way to do this is to find out the size of our hexagon points pre-instance. So let's go ahead and do that. Geometry bounding box. I'll join this up. I'm just using the node wrangler add-on. It all works. And I'm interested in, if I go into my Z position, so the maximum radius is going to be the X size. So let's go ahead and use a separate XYZ into my max value. And I can find this X here. This is our radius for a cylinder. Let's go ahead and use a mesh primitive cylinder. Vertices goes down to 6. Plug this into our radius. And I'm going to Control Shift right click to get those to join together. Oh, I plugged that into the Z for some reason. I mean the X. There we go. So we can see that this is now properly like on those edges. And if I was to do something like changing my less than here, then you can see that this is going to kind of match. It fits these nicely. I'm going to leave it at -20, which is fine for this. Also, a little thing if you're not aware of fields yet, if you want to inspect what a socket is putting out, then you can hover over it. It only really works for constant sockets, the round ones, because you can see a specific constant value. If I were to look at a grey socket, actually in this case it is putting out, because it's coming through a constant, that does work. But if you were coming through something like this, then it would say float field based on the attribute position. I'm interested in tweaking this, so let's go ahead and set my depth to 1, and I'm going to move it up, geometry transform, up in the Z-axis by 0.5. It's going to bring us up into the right position, and then I'm going to use another transform just because I want my scaling to be separate. Set that one to 0. Because you can see if I change the scale on this first one, we lose that bottom position, whereas on the second one, we're now going off that bottom position. So if I want this to be kind of within that space here, we can see this is 0.11. And so what this is going to be is around about half the scale coming out of here. So all I'm going to do is I'm going to add to the 2 min. Let's go ahead and actually add some of our stuff from the front of the node group. So we're going to use a group input node now. I'm just going to plug into 2 min and 2 max. These are our height min and height max. And I'm also going to plug this one into a combine XYZ. So our height min goes into the Z. And I can just bring this up and plug this into this one here. So if I go onto my object, into my modifier, if I start messing around with these, you can see that we have this coming in. Like that, we're changing the height of this. And that's working out all right. What I'm also interested in doing is adding a control for where these get taken away. So I'm going to set that to 0.5. I'm going to plug this in, and I'm just going to call this one erosion. So that I now have a control for where we lose our points into the sea. And I'm also going to use an add in here just for our sea level, so that I can have a controller again on that group input just to control sea level, just in case I want to, have no erosion and have my water level quite high. Sea level, there we go. So with this at 0, we can see that's fine. And if we increase this, then that is going to come up nicely. All right. I'm gonna leave it at 0 for now. Gonna reduce my erosion a little bit. And we can see, sometimes you're gonna want to bring this down. It just gives you as much control as you want, really. Okay, so I'm gonna delete some points. I'm gonna increase my sea level, just so it's not quite at those bottoms. And there we go. Now, if I was to start changing stuff like the resolution, well, that all works nicely. And if I want to move my texture, again, all works nicely. And it's really performant as well. This is one of the great things about working with geometry nodes, is it all just kind of works quickly. Now, what happens if I change my Z height? Just the Z, that can control the overall height. And we can also control this on the max height value as well, if you want that there. Okay, things are all starting to get a little bit crossed over, aren't they? Reroute some of these. Now, the next thing for us to do is to actually have different types of cylinder. If we want to have water for our general base one, and then we're going to have sand, grass, stone, and snow to make up the rest of this. Of course, you can use whatever textures you want, whatever shaders you want, and you can instance additional things on top if you want as well, which I know they did in the example that we're kind of going off here. First things first, let's create our cylinders. I'm going to do this in a new collection. I actually have one here called Hidden, which I'm just going to use. Let's go off to the side. We're going to add a cylinder, and if I pop this open here, change this down to 6. This is all fine, so let's go with that. This is fine as it is, except from our origin needs moving up. So let's go ahead and just grab Z1. There we go. So that is cylinder number 1. We're going to make 4 of these, 2, 3, and 4. And conveniently, they are different colors, so we'll be able to add shaders as needed. I'm going to go ahead and grab a collection input node, collection info node. I can delete these cylinders and transforms. Let's plug these into our instances. And I'm going to select my collection, which is called Hidden in mine. There we go. Now, this looks very cool, but it's not exactly what we want. Let's go ahead and make sure we are separating our instances, which makes sure that all of our points are different. We need to reset the locations, and we need to pick this. So this option tells us whether or not we want to pick the whole collection or just a single item from that collection. So turn on all 3 checkboxes, and now we have got ourselves a nice little array of hexagons. We can get rid of this rotation from our instance node, and this is all working nicely. Now, right now it just goes like 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4 on repeat, which is why we can see that this is a pattern here. And we actually want to use the instance index based on our noise. So go ahead and grab your map range. I'm going to Control Shift D on here. I'm just going to remove those bottom 2 parts there. I'm going to plug this into the instance index, and you can see immediately this is working quite nicely. If we're going from 0, 1, 2, 3, the values that we want really are like 0 to 3.99. I wouldn't go over 4 because sometimes you can end up cycling and picking your sand to go at the top of your mountains. It can be a bit annoying. But here we go. So now we can just change our inputs to change the sort of distribution there. Cool. So this has seemed to have done it in order, which is nice. So let's go ahead and just add some shaders now. I'm just going to go into EV preview, and we're coming along here. So let's make sure we can see the whole thing. Let's add a shader. We're going to add a new shader for the sand. Give something like this. So that's just going on there. And we're also going to add a shader for the grass. I'm just making these flat colors. Of course, you can do whatever you want. Green for that. I'm going to use a gray for a sort of stone patch where there's no foliage. And I'm just going to leave that as white for the rest of it. Now, what about our actual water? Well, you can make a blue texture if you want. I'm actually going to use the Materialiq one because, oh my god, the water textures in here are so good. So let's go ahead and summon a material using, in the glass and water category, we're using the water from a lake. Now we don't see it anywhere, we need to assign it to our hexagon. So let's go ahead, material, set material, and I'm just going to grab that there and save. So this is all working pretty nice. I think this is basically done. I'm just going to go back into my layout. I'm sure we'll see something in a moment, which I'm going to change. But for now, let's hide our inputs collection, those original hexagons. I'm going to go into rendered view. I'm going to go and just grab one of these default HDRIs. So I do just want to show you this water because it's so cool. It's animated as well. I don't generally get like material add-ons because I make a lot of materials, but this one is so good. Maybe, do we have any stronger sun? Let me increase the water level as well, just so that you can see. It's like a volumetric one. So you've got volumes, you've got caustics, which are really nice. And also they're like fake caustics. So even if you turn off caustics, you still get them. Let's go in here. Damn, it's so good. I mean, look at these caustics, they're beautiful. And the volume thing, it just feels like being underwater. And if you play it, you can see that this is all, and you get those like God rays coming through the, it just looks so good. It looks so good. Anyway, so that's the Materialiq add-on. It's by the same people who do Botanic, the popular foliage add-on. Anyway, let me reduce that sea level just so we can see things again. Go with this. Okay. One thing that you may want to do is bevel this. So I'm just going to add a bevel modifier afterwards. It's nice because it's kind of maintaining the, it's like maintaining all of the different objects as instances, even though you're beveling it, which is great. And also because this is happening after the scale, we're able to get a consistent bevel across everything rather than it being stretched according to how tall a point is. If I move my texture one, I think the bevel is maybe slowing it down. Yeah, a little bit. So if we move our texture empty, you can see that's pretty performant. I mean, that's pretty good on there. You can change the size of this, make it bigger, make it smaller, and obviously rotate it and do whatever you want to do. And, you know, make one of these and tag me in it. Just go exploring. These things are great. We can also change the resolution. If you make it too small and you find, like here, that you're running out of tile points, all you got to do is go into your geometry node setup and increase your X and Y count. So change this up to like 500. And that's just going to basically make sure that your tile stays like bigger than your mask area. Obviously then I could make this smaller so I have more land to explore. You will just need to be aware that your bevel, if you have really small tiles like this, may look a bit aggressive. So you might just want to tone that down a little bit. But again, isn't this just so nice? You can just go exploring. It's really lovely. And you can set the height of these things, which I would probably actually do with my world one. So let's scale this up a bit. What I'm actually going to do is I'm going to generally scale it up because this is hitting my performance a little bit here. All right, so you can change up your Z height on that empty. And that's just going to give you a little bit more variation in here, which is always nice. I'm not sure if it's just me, but I feel like the noise in Cycles X has got really bad recently. Like when you're moving around, this is like it's being bruised. That first pass is just not pretty. But anyway, we can increase our sea level a little bit. All right, I'm going to leave this as it is now, and I want you to go and have fun. Play with these, make your own world, go and explore it. All right, so there we have it, your very own hexagon world with all sorts of control for different things. Controlling the sea level, controlling the amount of erosion that you've got, controlling your your max and min height, and also just being able to control your textures, sort of scale, and your world scale, your resolution of the world here in essentially real time and in Blender. This is not Houdini. Obviously we're basing this on a Houdini project, but go and have fun with it. Go and enjoy the new procedural tools that you've got with geometry nodes. I'll see you in the next one.